particles are not fundamental elements of reality. Let's take an atom. Of course, you could take a smaller, simpler system, but I think with an atom it would be amazing because we're all taught that atoms are the fundamental elements, everything is made up of atoms and so on. So if you are able to put an atom in a superposition of being in two different places at the same time, what you now want to really test is that what the ultimate elements of reality are the Q numbers that pertain to each of these locations, and not necessarily the existence or non-existence of an atom in these places. And I think that's why first you need a superposition of an atom, and then you need to execute certain measurements in each of these places. In fact, what you are really testing is the amount of entanglement between these two locations. Schrödinger would automatically recognize this as an entangled state, because if the particle is not here, then it's sitting over there, and vice versa. So there are two branches of existence. And so these are experiments that would be very similar to what's required to violate Bell's inequalities.
Bell's inequality being a test that shows something is entangled.
That's right. It goes beyond the classical logic. That would rule out the interpretation where you could say, well, wait a second. Is it possible that the atom really is here or not here? It's just that I don't personally know, which is what frequently some people maintain, that it's all fine, things really exist or they don't exist, but it's just that I'm not aware of that. Until I walk into that room, I don't really know. This one rules this out completely because it says, no, it's nothing to do with that. If you were to suppose this kind of underlying reality, you could actually not violate Bell's inequalities. These would be hidden variables in the jargon of physics. So you can do a very simple experiment to show that any quantum, it could be light, and actually experiments have been done already with photons of this kind, and
they showed that you were right.
And they indeed showed the violation of Bell's inequalities. With atoms, it's much more challenging. They are really just technologically harder to do, but it seems to me that's one of the experiments that we could be doing.